Yes, the recording is started. You can write your roll numbers in the chat box. Recording is started. You can write your roll numbers in the chat box so that your attendance will be marked. Right. So in last lecture, almost first unit is complete. I think some homework was given to you. Can someone tell me what was that? I have given you some task. Some task was given to you. Okay. Let it be. When what we will do is MCQs of first unit we will discuss, because hopefully we will have the offline exam, but if not, we should focus on MCQs as well. So very first MCQ is, I hope, am I audible? Can someone respond?
Yes, sir.
Yes, sir.
Okay, only 33 students are there. 34. Yes, Rushikesh.
Nothing, sir. Sorry, sir. I was just checking what happens when I raise hand.
Rishikesh ji.
Yes, sir. Sorry, sir.
When we do that, no, we should ask some question. You have
Sorry, sir. I
no, you have raised
next time.
you have raised hand, so you have to ask some question now.
Okay, sir. I will not ask question, but the task was given that application of IoT.
Okay, good. ठीक है. So applications of IoT in industrial area, Deepika has rightly mentioned, and that actually I forgot. So in industrial area, can someone tell me any application do you find? Do you find any application of IoT in industry? Okay. So still no response. So I will add one more question with that. There is a term called as a industrial IoT. Industrial IoT, and which is abbreviated as IIoT. So this is second homework that you should complete. Application of IoT is one thing, and industrial IoT, right? So someone have to not someone, everyone will have to prepare one page write up on this industrial IoT, right? So two tasks have been assigned to you. One is application of IoT, that you need to search on internet, and you will have to list out the applications of IoT in industrial area. And second thing is, you have to write half page, let's say half page, not one page, half page write up on industrial IoT, right? So with that homework, let's proceed. I hope you will complete it by tomorrow. Yeah, we are discussing this MCQs of first unit. So first MCQ is IoT stands for. Very simple question, but I found in hurry most of the students select wrong answer. See, the options are very much similar. First option is Internet of Tools. In hurry, you can choose. You may choose. You should not choose. Right? So first option is Internet of Tools. Second option is Intranet of Things. Right? So which is very similar to that Internet. Next option C is Internet of Thoughts. And last option is Internet of Things. Obvious answer is obviously it is Internet of Things, right? So you should not make mistake in hurry. That's why I have specifically included this as a first MCQ. Second MCQ is, which of the following is not an example of IoT? First one is RFID. Option B, GPS tracking system. Option C, electric switch operated fan. Interconnected street lights in the city. Now, if you observe this RFID is one of the technique, or in fact, RFID has been treated as first IoT system, which is invented in 1960s, right? So RFID itself is a IoT. Then GPS based tracking, which requires the use of internet. Okay, so GPS is making use of internet all the way. Then we have electric switch operated fan. Now this you may consider the electric fan that you can operate at home, which is present at everybody's home, right? So in order to turn on that fan you should simply turn on the switch, and to turn off it you should close the switch actually, which is present on an electricity board. Now, is there any concept called as internet involved in the process? No. Internet is not required to turn on or turn off the fan, right? That is why you cannot call this as an example of IoT, right? So correct answer for this is, means, which of the following is not an example of IoT? Electric switch operated fan is not an example of IoT, right? Interconnected street lights require the use of internet. That's why it is IoT. Next is, internet is a vast global network of. Now actually we have discussed what is internet. Internet means vast or global network of what? It may include server, it may include computers, it may include mobile, tablet, and when all of these three, like server, computer, and mobile tablets, if all of them are interconnected, we call them as global network, or you can call it as internet. Just a minute. Swagat Karve sir is responding. So Swagat Karve sir will take lecture at 3 o'clock. Yeah. So if you have a collection of these three components, you can call it as the internet. Next is, Internet of Thing means a network of physical devices capable of dash 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 information over the internet. Now, what can be a suitable word here in this blank space? So let us put sending. Yes, of course, sending is possible in IoT. Receiving, yes, receiving is also possible. So communication, in short, we can call it as communication, or you can say all of these. So right answer is all of these. So Internet of Things means network of physical devices capable of sending, receiving, and in turn communicating information over the internet is the right answer. So correct answer is all of the above. Next one is dash 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 means a network of physical devices. That simply means it is same like fourth MCQ. So IoT Internet of Thing is the answer. You should not choose cloud or server or client. Next one is which of the following are part of IoT framework? Which of the following are part of IoT framework? So IoT framework we have seen. We have studied the IoT framework, and if you know the IoT framework very well, you can easily identify that physical object is the part of IoT framework. Controller, sensor, and actuators are also the part of framework. Right. So physical object is a part of IoT framework. Then controller, sensor, and actuator is a part of framework. Internet is also a part of IoT framework. So correct answer is all of the above. Next one. Which of the following is not a function of IoT? Sensing is not a function of IoT. Sensing is a function of sensor. Otherwise, in IoT, you can see a gathering of data, streaming of data, and management of data is possible at IoT. But sensing of physical phenomena is the role of sensor. So, which of the following is not a function of IoT? Sensing is not a function of IoT. Right? So, correct option is A. Role of role of application layer in IoT architecture is so reporting, analysis, control, and all of the above. So at application layer in IoT does all those things: reporting of data, analysis of data, controlling of information. Right. So all of them is correct. So answer is D. All of the above. Next, which of the following is not an IoT platform? So, some of the IoT platforms we have seen in the last lecture. Uh, Intel Galileo is the IoT platform. Raspberry Pi is also an IoT platform. Then BeagleBone is also an IoT platform. But CoAP is actually a protocol. It's not IoT platform. So this one is not an IoT platform. So if the question is asked, which of the following is not an IoT platform, you should smartly select CoAP because CoAP is application layer protocol. It's not an IoT platform, right? आपण काल बघितले होते हे इंटेल गॅलिलिओ then Raspberry Pi, BeagleBone. These are just an IoT platforms, but CoAP is application layer protocol. Constrained application protocol is the long form of this CoAP. Then, which of the following is not a type of processor? DSP. What does it mean, or what this DSP stands for? Can someone tell? What type of processor it is? It's a digital signal processor. Then next, ASSP. Can someone tell me what is ASSP? Is there anyone who can tell what is ASSP? Have you heard the word ASSP? Can you tell me what is ASSP? What is P2P? What is ASIP? तुमच्या हातात मोबाईल आहे. I told you immediately what you can do is you can minimize the window. You can minimize the Google Meet and you can search and you can answer. What will happen with that? I'll tell you. You will be able to resolve the queries at runtime. मी इकडे क्वेश्चन विचारतो. ऑफकोर्स most of us means most of the teachers will be telling you that ki, sir students should not copy from Google and all that, but here I am allowing you to copy. Here I am allowing to get your query resolved from Google. So search on a Google and tell me what kind of processor it is. ASSP. I give you 2 minutes. I can tell you first 2 words. Application specific. Next.
Application specific standard product.
Standard product. Okay, it's related with the processor. You check with this application specific. Then let me tell you, it is system. S stands for system and P stands for processor. So application specific system processor. Next, P2P. It's not related with the processor, so that is why it's a correct answer for this. So which of the following is not a type of processor? P2P. P2P is a type of communication, not a type of processor. Now, again, I give you 2 minutes. Find out what is ASIP. ASIP.
Procure to pay.
Sorry. What is ASIP? What is ASIP?
Application specific instruction
Set processor.
set processor.
Correct. Very nice. Very nice. So at least with that you should be able to search. Somebody said procure to pay. So with reference to electronics terminologies, you should be able to find. आता तुम्ही हे ASSP टाकला तर दुसराच काहीतरी अमेरिकन स्टँडर्ड असे queries resolved होतात. But you should mention a proper keyword so that you will get your query resolved by the Google. Google करणं सुद्धा इतकं सोपं नाही आहे जेवढं तुम्हाला वाटतंय. ठीक है. So if I ask you to write a note on this ASSP, you simply search ASSP on Google. What it will shows? Simply search ASSP. It will show you American Society of Safety Professionals. This is what will be displayed there. But
Yes.
I am asking the question related with the type of processor. So that has to be related with application specific system processor, right? So learn how to Google, how to get the query resolved. Why I'm telling you this? If you are trying to become a, let's say, software developer, lot of things are available readily on the internet. The way in which you make the use of that, the way in which you are able to search it, will make you effective or will make you smart, right? So if let's say if you are a back-end developer, or let's say you are front-end developer, being front-end developer, are you really going to develop something new? No, absolutely not. The logic is given to you, and based on that logic you will have to design your own code. But You are not going to write any code for small things which have been already done. For example, if I want a delay of, let's say, 5 seconds, right? So do I suppose to write the delay of 5 seconds? No, absolutely not. The subroutine to generate a delay of 5 seconds is already there in existence. I don't have to write separate code for that. I just have to search on a net. I have to get it copied and I have to paste it in my script, in my main program. Are you getting what I mean to say? Right. So next is which of the following is not an IoT protocol? Which of the following is not an IoT protocol? So here you can find MQTT as a first option. It stands for message queuing telemetry transport. Second one is CoAP. It is constrained application protocol. Then third one is Arduino IDE, and last one is HTTP. Of course, the answer is Arduino IDE. Arduino IDE is not an IoT protocol because it's a software that is used to edit, write, compile, and upload the program on the Arduino hardware. It's not a protocol, right? Otherwise, rest of the things are protocols. So one more thing you can search on a Google. Yeah, I don't know the long form of this. You find it. HTTP, hypertext, something like that. Search on a Google and tell me what is the long form of HTTP.
Hypertext Transfer Protocol.
Correct. Hypertext transfer protocol. Right. So it is again a protocol. CoAP is also a protocol. MQTT is also a protocol. So HTTP is also a protocol. So by default, you should choose Arduino IDE, even though you don't know about it. So I hope all of you are knowing this Arduino IDE, but even though if you don't know that, you should be able to choose it. Right. So next is dash dash is not a component of IoT. Now here, hardware, of course, it's a part of embedded, and embedded is a component of IoT. So hardware is a part of IoT. Next, software is a part of IoT. Then communication, that means internet, is a part of IoT. So none of the above. None is not a component of IoT. Next, sensors are electric devices that dash 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 the physical environment. We know that sensors cannot change the environment. Sensor cannot change the physical environment. Sensor cannot record the things in real time. It cannot monitor because it do not have some additional output interface. That's why it cannot monitor the physical environment. Right. So sensor does only one task, and it is sensing. Next is type of sensors are analog sensor, digital sensor. So correct answer is both A and B. Next, which of the following is IoT communication technology? So here I have listed some communication technologies. One is BLE. BLE stands for, let me tell you, Bluetooth Low Energy. Bluetooth Low Energy. It is extension of Bluetooth. I think right now class 3 or class 4, version 4 of Bluetooth is going on, but it's a low energy version of Bluetooth. And I hope all of you are aware of those Bluetooth Airpods, right? Wireless Bluetooth, or what people call it as Airpods, right? So this BLE technology is enabled in those devices. जे कानामध्ये छोटे छोटे एअरपॉड्स घालता तुम्ही, ब्लूटूथ इनेबल्ड असतात ते. They works on BLE, and what is the logic behind this BLE is the device or the headphone that you are using, Bluetooth headphone, is made to go in a sleep mode continuously, and as long as there is no signal from the mobile, it will remain in a sleep mode. As soon as the signal is detected, as soon as you turn on the music, or as soon as you turn on the call, as soon as you receive the call, your Bluetooth low energy device, that is AirPod, is getting activated, and for that duration of time, only for that duration of time, your device, that is BLE, will be active. Afterwards, as soon as you turn off the functionality, as soon as you stop the music, this BLE device will again go into the sleep mode, and hence most of the power is saved. Zigbee, we know this Zigbee very well. Of course, we have to discuss one complete unit on those four technologies: Wi-Fi, Bluetooth, Zigbee, and RFID. Right. So these are IoT communication technologies. Right. So this is answer is all of the above. Next, cloud is a model of computer data storage in which digital data is stored in logical pool of storage devices. Then pen drives, micro SD cards, none. So correct answer is logical pool of storage devices. You don't know where the data is being stored. So the subclassing is done logically, right? And suppose I'm sending you a couple of files. Let's say I'm sending you this MCQ file along with the video recorded video lecture, along with, let's say, PPT, along with some handwritten notes, right? So depending upon the file type, it may be classified and distributed over the different over the clouds which is located at different geographical area. म्हणजेच काय थोडक्यात सांगतो, the image, सपोज आय एम सेंडिंग यू ऑल दोज फाईल फॉर्मॅट्स, म्हणजेच मी तुम्हाला इमेज पाठवतोय, त्यानंतर PDF, वर्ड फाईल, PPT फाईल अँड व्हिडिओ फाईल. So you cannot say that all the data that I have shared with you is located at one place. It will be logically divided, and maybe images, let's say images are present in some city like Mumbai, then word files may go to the Pune, then video files may go to the Bangalore, and different server locations are there at those cities. So whenever I call all those things together, all those things means what? Image will come from Mumbai, then audio file will come from Pune, then video will come from Bangalore, and the data is presented to me as a bunch of this thing. I will at the client side, I will not be able to see that the image is stored at this location and I'm getting that image from this location. At the client side, you will not be able to see that, but they are logically separated, and the data is stored like this only. Then pen drives, micro SD, this is not the case. Cloud will not work in this fashion. Then cloud hosting company is responsible for, means what? Here are the roles of cloud hosting service provider. So they should keep the data available. The data should be available all the time. This is first responsibility. We have seen that. Next is maintaining security and privacy. Yes, of course, the cloud hosting or service provider should maintain the security of data, and they should maintain the privacy as well. Next is keeping the physical environment protected and running. Of course, the cloud service provider must maintain the environment. Maintain the environment means what? They should keep this cloud environment protected. Nobody should have access to that environment, and it should be running all the time, 24/7. Right? Meaning of that, whenever you access the data, it should be presented to you. असं व्हायला नको की तिथं लाईट नाहीये, मग मी सेव्ह केलेले व्हिडिओ लेक्चर तुम्हाला दिसणारच नाहीत. नो, इट शुड नॉट हॅपन. इट शुड बी रनिंग 24/7 hours. Which of the following is not a cloud hosting company? Amazon AWS, I told you. Files Anywhere is also a cloud hosting company. ComServe is also a cloud hosting company. Intel manufactures the processors, so this cannot be comes in this category. right? So cloud hosting companies, Amazon, Files Anywhere, ComServe, not this Intel. Next is as per IoT Conceptual Framework, gather, enrich, stream, manage, acquire, organize, and analyze is nothing but your IoT. I told you this is some sort of framework. I told you, and in that it's a framework of Internet of Things, right? Here in which gathering of data, enriching, streaming, managing, acquiring, organizing, and analysis of data is carried out. So if the system is doing this, we will call it as the Internet of Things. Next, as per IoT architectural view suggested by Cisco, level 3 deals with. Now, can someone tell me what is level 3 and what are the functionalities? So you can go back and you can check the notes. Level 3 deals with edge computing, not related with the data abstraction, data accumulation, or connectivity. Next is, which of these can be considered as sensory organ for IoT? Of course, the sensors. Sensors will act as a sensory organ for IoT. Right. So these are all about the MCQs. These are all the MCQs that are related with the first unit, and most of them have been asked in university examinations as well. Right. So if you have any doubt in MCQs, you can ask. Shall we proceed further?
Yes.
Okay. Right. Okay, then let's move on to second unit. Right. So I hope the screen is visible, and we are now talking about second unit. We are discussing this second unit, and the title of second unit is Embedded Systems for IoT. I told you what is embedded system. Embedded system is one of the component of IoT. Just keep it in mind. Embedded system is one of the component of IoT. Right, and in second unit we will deal with this complete embedded system. Now recommended textbook is Internet of Things by Raj Kamal, and reference book is Internet of Things IoT Systems Architecture and Algorithm Methodologies. Right, so as I said, you need to borrow this first textbook, that is Internet of Things by Raj Kamal. So whenever you visit our campus, please try to get this book issued. These are the content, not the content. Actually, this is the syllabus of a second unit, which consists of introduction to embedded system. This is first point. The next one is different components of an embedded system. Then basics of microcontroller based embedded system. Then next one is basics of Linux based embedded system. Then next point, second last point, is various embedded platforms used in IoT. And last point of this unit is understanding the various IDEs used for embedded development. So this is the syllabus of second unit. I hope you will make a note of this. I give you 1 or 2 minutes time. Once you note down those points, once you note down the syllabus, please tell me once you complete the write-up part. I give you time to write this, maybe 1 or 2 minutes. सिलेबस एकदा हाताखालून जाऊ द्यात. Done?
Yes.
Okay. So let's begin with the first point, that is introduction to embedded system, right? So this is what first point of this second unit is. Let me tell you in short what we are going to discuss overall. Here we will talk about the need of embedded introduction of embedded system, then why embedded system is required in IoT, then what are different components of embedded system. बघा आपण डिफरंट कॉम्पोनंट्स ऑफ आयओटी पाहिले पहिल्या युनिटमध्ये. त्याच्यामध्ये पहिलाच कॉम्पोनंट होता एम्बेडेड सिस्टम. नाव हिअर वी आर टॉकिंग अबाउट कॉम्पोनंट्स ऑफ एम्बेडेड सिस्टम, right? So whatever components of embedded system are there, they are ultimately going to be a component of IoT, right? So I hope you understood what I said. Embedded system is a component of IoT, and here in this unit we will talk about components of IoT, right? Then we will see what is microcontroller based embedded system, how it can help in controlling the things. Then Linux based embedded system. So here we will talk about some software part. Then various embedded platforms used in IoT is also discussed. IDEs also we will discuss, like Arduino IDE, as I said. What are other Arduino? What are all other options are available? We will discuss at the end of this unit, right? So let's begin. Introduction to embedded system, and very first characteristic mentioned here is single function. But before going to that, let me define what is embedded system. Embedded system is the combination of hardware and software which is designed to perform some specific task. So this is you can say dictionary definition or all that. But can someone tell me the what is meaning of embedded? The word is very specific and not used anywhere in general, but you should be able to tell me the meaning of word embedded. What is embedded? What is embedded? बघा मी आत्ताच सांगितलं तुम्हाला काय करता येईल. जर आन्सर माहित नसेल तर you search on the internet. Embedded means what? You may consider this word as attaching with something, or you can call it as a interfacing with something, or you can call it as fixing with something, right? So if in electronics terms, what I can give you analogy is, if I am interfacing ADC with microcontroller, I can simply say that it's the ADC is embedded with microprocessor or microcontroller. Microcontroller, I can say that it is embedded with microcontroller, right? And that is why we call it as my embedded system. The main processor or controller, and surrounded by which you can have all other peripherals togetherly system that performs some specific task, and we will call it as a embedded system. Now, there are some characteristics of embedded system which actually used to identify the embedded system, and in that first one is single function. So can someone tell what is single function? Single function means what? At a time it will keep on performing a single. So if I'm having an embedded system called as a washing machine, it will be used to wash the clothes. used to make the phone calls. I hope you understand what I mean is, if I'm having an embedded system called as a washing machine, it will be used to wash the clothes. It will not be used to call the, it will not be used to make a voice calls. It will not broadcast the television signals, right? It will not be used to cool the temperature of your room like AC. Right, so this is what we call as a single function. It is designed to perform a specific task like this, and it's a single function. Another aspect, another characteristic is tightly constrained. So can someone tell what is constrained, or what is tightly constrained? What do we mean by tightly constrained? What do you mean by tightly constrained? I can give you the analogy. Tightly constrained means there are a lot of restrictions on design part, right? So let's say, let's take an example of a student from your class, right? And you are tightly constrained. So let's assume the scenario when the offline lectures are going on. So what are the constraints? You have to be in the college at 8 o'clock morning, 8 o'clock sharp. If you don't reach in the class, reach in the department sharp at 8 o'clock, you need to pay the fine, right? So this is second constraint. Reaching on time, uh, actually every day attendance is mandatory. This is first constraint. Reaching in time, another constraint, right? Attending the lecture, third constraint, right? Doing pranayam, another constraint, right? So wearing uniform, proper uniform is another constraint. Wearing shoes, a constraint. Wearing tie, another constraint. Having this iCard, another constraint. So can you tell? Can you say yourself like you are tightly constrained? Yes, you are tightly constrained. All those disciplinary things which have been set as a constraint have to be followed. Right? Very similar to that. Why I have given you this analogy is embedded systems are also tightly constrained, right? So all the computing systems have constraints on their design metric. This is what I wanted to highlight. But those on an embedded system can be especially like design metric, in which measurement, what are the different constraint actually for embedded system? There have to be a cost, right? What should be the cost of embedded system? Can someone tell? Of course, the cost of embedded system should be low as much as possible. So this is first constraint. Second constraint is size of the embedded system. So how much would be the size of embedded system? Of course, the size of embedded system should be small as much as possible. Then power requirement. So if you talk about power, it should consume a low power as much as possible, right? Then performance, it should be its performance should be high. As far as speed is concerned, as far as frequencies and response time is concerned, it should be effective. It should be optimal, I can say, right? So a lot of constraints are there on an embedded system. So it must be of small, and a single chip must perform fast operations. It must process the data faster enough in real time and consume minimum power to extend the battery life. So these many are the constraints of embedded system. So that is why it is tightly constrained. Next one is reactive and real time. This is very important characteristic of embedded system. Reactive and real time. Meaning of that, what is the meaning of reactive? What is the meaning of reactive? अरे रिएक्टिव्हचा अर्थ माहित नाही कोणाला. व्हॉट इज रिएक्टिव्ह? Reactive means the thing which respond immediately. Reactive means what? It respond. Which respond. Example I can give you here. The example I can give, let's say Rishikesh. Rishikesh More is there. Are you able to hear me? Rishikesh? I need to check who is present. Vikram ji, are you there? Vikram More. Vikram, are you there? Upendra. Upendra, are you there? Hello? Upendra?
Yes, sir.
Got the response. Right. So I was talking about reactive and real time. So I was focusing on the first word, that is reactive. What do we mean by reactive and all that? That is what I was talking. Now, the example of reactiveness I can tell you. Suppose somebody slap Upendra. What will happen immediately after that? Suppose Digvijay Chakote slap Upendra. What will happen immediately after that? Of course, so Upendra will slap him back. Why? Because Upendra is reactive. But what will happen? Sudarshan, yada zala kai? Upendra ji, you meet Sudarshan Koli afterwards.
Yes, sir. Yes, sir.
Find where is he and meet him. Huh?
Yes, sir.
Okay. So I was talking about reactiveness. Non-reactive. When I can say non-reactive. So somebody slapped like Digvijay Chakuti, if he went and slap some person like Mahatma Gandhi ji, what will happen if he slap one this thing? तुम्ही काय त्याला एक कानाखाली मारली तर बाबा मार दुसरी पण म्हणणार, राईट? सो दिस इज व्हॉट नॉन रिएक्टिव्ह. हिअर द एम्बेडेड सिस्टीम मस्ट बी रिएक्टिव्ह. म्हणजे काय की जर त्याला तुम्ही इनपुट दिलं, इट शुड प्रोड्यूस द आउटपुट. तुम्ही इनपुट देताय आणि त्यांनी काहीच आउटपुट प्रोड्यूस करत नाही, दॅट इज नॉन रिएक्टिव्ह एम्बेडेड सिस्टीम. सो युअर एम्बेडेड सिस्टीम शुड बी रिएक्टिव्ह. अँड सेकंड थिंग is it should be real time. So getting the input and producing the output, there should not be any delay. That is what real time. म्हणजे जसे इनपुट येईल तसंच immediately without any delay it should produce the real time response, right? Best example I can give you. So many embedded system that must usually react to changes in the system environment and must compute the certain result in real time without any delay. So consider an example of car cruise control or automatic braking system. It continuously monitors, it continuously sense the impact, right? Automatic braking system means what? Suppose you are having some impact sensors placed on the bumper of a vehicle. So as soon as this impact occurs, immediately it responds to the, or before occurrence of that impact, it should respond to the system and it should produce the output. Producing the output means applying the brakes. So before the impact is occurred, it should apply the brakes. This is what the reactive and real-time embedded system. This is the example of reactive and real-time embedded system. आता विचार करा, suppose the embedded system is not real-time. म्हणजेच काय? Between input applied and this one output produced, there is a huge amount of time delay. म्हणजेच काय, इम्पॅक्ट सेन्सरनी इनपुट डिटेक्ट केलंय, इम्पॅक्ट डिटेक्ट केलाय, आणि त्यानंतर इट विल कीप ऑन कॅल्क्युलेटिंग द थिंग्स अँड इट विल देन प्रोड्यूस द आउटपुट दॅट इज नथिंग बट ऍप्लिकेशन ऑफ ब्रेक. सो इफ इट टेक्स लेट्स से 5 or 10 सेकंद ऑफ टाइम, इम्पॅक्ट डिटेक्ट झाल्यानंतर 5 सेकंदांनी ते ब्रेक अप्लाय करत असेल तर इमॅजिन द सिच्युएशन व्हॉट विल हॅपन. समोर एखादा ऑब्जेक्ट, एखादी मोठी वॉल किंवा मोठा ट्रक आलेला आहे. Before after detecting the impact, it's applying the brake after 5 seconds. Imagine the situation, what will happen, right? म्हणजेच काय की तुम्ही इकडून इम्पॅक्ट डिटेक्ट झाला तरी पण एक 5 सेकंदांनी त्याच्यावरती ब्रेक अप्लाय केला जाणार आहे. सो इट विल बी ऑफ नो यूज, राईट? So it should be reactive and real time. That is why embedded systems are significant in nowadays vehicular automation. So this is one of the characteristic of embedded system. Next one is, it is microprocessor based. It is microprocessor based. So we will talk on this characteristic tomorrow. Tomorrow at what time we have lecture? I think tomorrow is a project day for you. Let's talk on this this one. I'm talking about this microcontroller based, right? So we will talk on this this characteristic in next lecture, right? So if you have any doubt, you can ask. Otherwise, if you don't have any doubt, you are allowed to leave the meeting.